Well, students, now question number 4, blueprint questions. Why do we fall in forward direction when a moving bus brakes to a stop and fall backward when it accelerates from the rest? As you have studied the inertia of rest and inertia of motion. In the first part, when the bus is moving, the passengers are in the state of motion along with the bus. And when the brakes are suddenly applied, the bus comes into rest. And the passengers, they continue in the motion due to inertia of motion. Hence, they continue in motion in the forward direction. So, they fall in the forward direction due to inertia of motion. In the second statement, when the bus is in the state of rest, it means the passengers are also in the state of rest due to inertia of rest. When the bus accelerates, it means starts moving, the passengers are in the state of rest, so they fall in the backward direction. Now, next page, blueprint question. The first question, question number 5th, it is, if action is always equal to reaction, explain how a horse can pull a cart. Yeah, according to Newton's third law of motion, we have studied that action and reaction are equal and opposite. Then, as horse pushes the ground with its foot in the backward direction, this is the action force by pressing the ground, and when the horse pushes the ground backward direction is the action force, and then ground pushes the horse in the forward direction, this is the reaction force. Hence the horse pulls the cart as it is attached with the horse, because horse it will move in the forward direction. Next question, explain why it is difficult for a fireman to hold a hose with ejects large amount of water at a very high velocity. When the water ejects from the hose with a high velocity, it has high momentum, and to conserve the momentum, the hose tends to recoil, so it is difficult to handle it. In another way, we can explain that the water which is ejecting from the hose in the forward direction, that is the action force, and the reaction force is also as much as the action force, so we feel a jerk, or we are not able to hold the hose pipe in a proper way. Now these are the numericals which can be explained with the help of this linear conservation of momentum. From a rifle of mass 4 kilogram, a bullet of mass 50 grams. Two masses are given. One is mass of rifle and other is mass of bullet, is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. So what are the things which are given here? Mass of rifle, it is 4 kilogram. Mass of bullet, it is 50 gram. Convert it into kilograms, then it is 1 upon 20 kilogram, or either we can say 0.05 kilogram. Velocity of bullet, it is 35 meter per second. Velocity of rifle, that we have to find out. Initial velocity, because rifle and bullet both are at rest, then their initial velocities, they are equal to 0. So according to law of linear conservation of momentum, we have momentum of rifle is equals to momentum of bullet. mv is equals to m small v. So mass of rifle, it is 4 kilogram, and velocity that we have to find out, and mass of bullet, it is 50 grams, and velocity, it is 35 meter per second. Now we can solve this equation. We will have the velocity of rifle, that is 0.438 meter per second. Now the next question, similar question is there, but collision is there. Two objects of masses 100 gram and 200 gram are moving along the same line and same direction with velocities 2 meter per second and 1 meter per second respectively. They collide. It means these are the velocities, they are before collision. They collide, and after collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. this is 100 gram mass and this is 200 gram mass. Initially this is moving with 2 meter per second and it is moving with 1 meter per second. Now they collide with each other, there is a collision. Then the first one, it will move fast, that its velocity is 1.67 meter per second, and the second one, its velocity is that we have to find out. So what are the things given in this question? Mass of m1 is equals to 100 gram, that is 0.1 kilogram. Mass m2, it is 200 gram, 0.2 kilogram. Initial velocity 2 meter per second, initial velocity of second, that is 1 meter per second. Then v1, it is 1.67 meter per second. V2, that we have to find out. So according to law of conservation of momentum, what we have, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Substitute all these values, then this momentum before collision, it is 0.4 kilogram meter per second, and momentum after collision, that is 0.167 plus 0.2 v2. Then the velocity v2 is equals to 1.165 meter per second. So students, you have to do the exercise questions, all the exercise question. Where you find difficulty, you can send these questions to me.